Hello, everybody. Welcome to our webinar series. My name is Jan Labohi. I'm CEO of World from Space, and I would like to invite you to this series where we will discuss about the current trends in the precision farming and space data. Thank you for answering the initial poll. I will end it now. We asked you what do you think are the key trends for AgTech this year, and we can see that the three biggest are, based on your opinion, AI tools everywhere, biggest corporation getting into digital farming, and regenerative agriculture. Thank you for this sharing. I think that we have the similar views on this. And let's get directly to the webinar. It should be about 30 to 40 minutes, just to refresh you during the day and give you some more insights into how the area is shaping and changing. Welcome to our first webinar. It's called Trends for this year, and it's looking at precision agriculture and space data. So let's get to the series. We will have 4 topics this year, always to 20 to 30 minutes to give you the inspiration. Today we will look at the major trends on a bigger picture, and then we will deep dive into the 3 different use cases on the field crops, on the soil monitoring, and then on orchards, vineyards, and other minor use cases. To give you a background of who we are and what we do, our company is called World from Space. It's about 5 years old, from Brno, Czech Republic, and it's focusing on enabling use of satellite data in agriculture and through production value chain. We've got experience in working with the European Space Agency and the EU SPA, also on R&D projects with the agriculture universities and big farms. And we would like to really thank the eShape project under the Horizon 2020 program that enables us to do activities like this kind of webinars. You've already made your pick of the 3 biggest trends, and I made my pick, and those are these 3. They are somehow similar, somehow not. Those are not all the trends, not everything which is happening in AgTech, but in these 20 minutes we can carry only a small part. So we will mostly look at the vertical integrations and embedded fintech, how this goes into the agriculture. We will look at the war of aging giants, and on mainstreaming of variable rate technology. Today, we will not have time for regenerative agriculture, which we discussed in a webinar series last year. You can still find it on our YouTube, or on other interesting topics like the genomics and remote sensing, combination or interoperability and connectivity, or lack of VC funding in this year. Those are key things, but let's focus really on the top 3, which we have here. Also, the AI will not be here. I think that everybody's talking only about AI today, so let's just have something else. If we look at the biggest picture, and I'm sure that you've heard this a million times, let's just repeat once more what are the key 4 problems we have in agriculture. The first one is the consumption growth. So we have more people on the planet, and the diet is changing. People want to eat more meat, and we need to produce the food for them. The other problem is the soil depletion and degradation, because the current agriculture practices are not really soil friendly, and they're overusing the soil, so its quality is decreasing. The thing we saw last year is really unstable prices of inputs. We saw a huge rise in fertilizer industry, which was causing major problems. We have also a long-term labor shortage, because agriculture is not that popular part of industry. Not that many people come from universities back to the industry, and also the seasonal workers didn't come back after the COVID when they returned home. And overall, the climate challenge is also part of the agriculture challenges. So in everything we do, we still need to take care of this. But when we talk especially about the space data, how can space help to solve these 4 problems? So in the first and the major way is the increasing yields and effectiveness of the whole system. So using less energy to gain more food for more people. The second part is lowering costs of the production, so using less inputs, like less fertilizers, less seeds, to achieve the same level of yields and outputs. Limiting workload is a very important thing by limiting the on-field visits or field scouting or the insurance people who need to go to the fields. We're able to somehow solve the problem of less workforce in the agriculture. And the last one is the supporting of regeneration of the soil and connected climate change mitigation activities, how to keep more carbon in the soil and increase its fertility. So those are really the big picture, how the space helps. And let's look more into who are actually the main user groups. And directly from them, we can get the first mega trend for this year we identify. So the farmers are usually the thing. When you see agriculture, you think about farmers, and of course they are the largest by count group that can benefit from the space data for supporting the precision farming practices, like the variable rate fertilizing that we will talk later on. But it's not just about the farmers. We have also the insurance companies that are providing the insurance services to farmers, which are now switching to use space data to provide better services, better and cheaper. For example, the parametric insurance, which is based on Earth observation space data and providing a cheaper solution for the farmers, which is unlocking a very big amount of potential users, especially in the developing countries. But in finances, it's not just the insurance companies, also the banks are using the space data in their green loans initiatives to understand better how the farms are working, what are the conditions of the field of the farmer, and if actually the loans and the financing that they are providing is compatible with their ESG standards, if it's beneficial, and if they can really expect the return on investment. The large group that you are meeting every day are the food producers, the companies that produce our foods, and they use space data to increase the traceability. So you better understand where the food is coming from, in what kind of agriculture it was produced, if it was organic, regenerative, or standard agriculture, but also for supply chain monitoring to understand if there will be enough potatoes for their fries or enough wheat for the bread. So that's a big group which is connected to the traders that are using the space data to understand how the commodity prices will change. So if there will be a shortage of wheat in a certain region, if the potato prices will go up or down. And in the end, it's also the big governments and big enterprises who want to control what is happening and understand what are the practices that the farmers or other parts of the chains are doing. So they're using this. And if we look at it, we can see 6 different user groups. They're using the same technology, but each of them is paying for it, which means that there are a lot of companies that do it, but the benefit is spread. And we need to understand and ask our 3 questions, because the system is very fragmented and the benefits and the costs are not evenly spread. So who has the biggest benefits in terms of money and the return on investment in this user group? Usually we would expect it would be the farmers, but it's not, because they are the individuals. And the benefits are accumulated on a scale. Like in other Earth observation products, the scale is the key thing. So the larger the company is and the higher turnover it has, it's harnessing the larger benefits. So it's getting more to the food producers or insurance or banks that have the highest benefits. But when we look at the costs, who pays most? It's mostly the farmers actually today, because they need to change their practices, they need to implement it, they need to buy a lot of machines. And again, the benefits are split in all the value chain, because if they do something better, it's not just they are paid for it, but you've got better food, and the banks get their money back, and they can provide the loans to some other companies. So the costs are also unevenly spread. So the question now at the whole sector is who should pay for these services if basically the technology behind is the same and the benefits are somewhere spread. And the first trend that we look at this year is the integrated solutions. So solutions that are actually putting together all of these pieces and not providing the individual offerings, just the services for farmers, or just the insurance, or just the financial services, but providing one service at all, which enables to lower the price and to split the benefits evenly. So it means that the farmer can use the system to optimize the fertilizing, while the same system can be used to offer him insurance or a green loan for better conditions, or even enables the food production company to see what the farmer is doing in one system. And this enables that the person and the entity that is paying, maybe the food production company, which was they have the biggest benefit, can split the other benefits into the other groups. So we see this more and more, that the fragmented market is becoming integrated, and more subjects are trying to think of how to put more offerings together. So this is the embedded fintech, for example, where the green loans and the financial products are offered through the software or services that were usually part of a different vertical, for example, the agriculture software or mobile applications for farmers. Or it can be the parametric insurance, which is together with the crop monitoring that the farmer can use. So this is a big trend. Companies are looking at it. And as you pointed out in the initial survey, it attracts a lot of attention from basically everybody who is already in the sector. So it can be the hardware manufacturers, the tractor producers, the companies like John Deere, Claas, that are now building their digital platforms in order to serve their customers, but also enable marketplace for other services to be sold through their vertical. It's also the other strong subjects like the fertilizers or plant protection producers that are, again, they're creating their digital platforms in order to sell the services to farmers together with their core business. So those are the producers, but we see also the software applications like the Farmer's Edge in Canada that started offering insurance, or it can be these insurance companies that also try to connect their services with the farmers. And recently we also saw the launch of the biggest technological players and their entry into the market. Microsoft signed a big deal with Bayer to work together on a digital platform. Amazon Web Services signed a contract with Leaf to provide the connectivity and cloud platform for agriculture data. Alphabet, the Google's mother, has unveiled is actually funding AgTech startups for several years, and they only now came into the visible space. So basically, all of these giants are now coming into the place, and they're trying to capture the digital farming services area, which is being integrated and embedded with different verticals. In space data, especially, we've seen in the last years rise of the planet, that their initial business model was to sell only the data from their satellites, but as we can see from their acquisition strategy, in the last 2 years, they actually bought 4 companies that are somehow focused on agriculture, being it Vandersat, which was a very high tech company focused on soil moisture monitoring and combining different multispectral and passive star satellites together for agriculture monitoring, or the latest acquisition of Synergize, the Slovenian company providing the Sentinel Hub service, which is also working on a lot of projects on the common agriculture policy monitoring in Europe, so monitoring agriculture activities We can see that Planet's strategies is to get into agriculture and really capture this market, not just with the data, but also with the insights and getting them into this digital farming services area as the main provider. So those are the key players, and this is the bigger, let's say, war which is happening, who will cover what. And if you look at the ongoing battles, let's say, we have now this mainstreaming of variable rate technology, which is a technology we've already discussed for 15 years. It's not something really brand new, but what is really changing is it's mainstreaming. So we've already passed the time when it was adopted only by the first pioneer users. What is happening now is the mainstreaming, which means that it's becoming really the standard way of operations. And we had historically five different borders which were there and barriers, which are now being removed. So the first one was awareness. Really, farmers didn't know why to do the variable rate technology. The technology which is based on the field heterogeneity. As you can see on the right top picture, a lot of the fields, like most of them, are variable, which means not all the field has the same yield potential, not all the field has the same soil quality, and traditionally the agriculture treats the field as one unit and gives the treatment the same all over the field. But with the variable rate technology, we are now able to provide each part of the field only the special amount of fertilizer, seed, or crop protection which is necessary. Farmers didn't really understand how this could happen for many years, but this has really improved, especially last year when the prices of the inputs has risen, and it really created a big push on integrating this. The other problem used to be the hardware, because not many farmers were actually able to buy the hardware which was compatible with the variable rate technology, which again is not the case anymore. Most of the producers of the sprayers and similar hardware are already variable rate technology compatible, and in their strategies, all of them, they believe that it will be the mainstream. So the hardware is ready. Software problem means how to get the information about where to put more and where to put less into the hardware. This is still kind of a problem because of the compatibility and interoperability problems, how to get the map into the tractor, but it will be solved in 2 to 3 years. Now, a lot of solutions are already compatible, and it's less and less problem. Where to get the maps for it? There are providers for this. Some provide better maps, some worse maps, but you can get a map from satellites, from drone, from soil sampling. So this is already covered, and these services are standard on the market. And the connectivity I've already covered. So it's still a problem, but it's still less and less problem. So that's why this technology is becoming mainstream and is becoming really adopted at scale this year. And the reason behind is because it has already proven results. They're always, 5 to 40%, you can say almost about anything. The problem here is that the variability of the field is determining the results. So if the field is really heterogeneous, you have different yield potentials in different zones of the field, you can save a lot. If not, then you don't save almost anything. But saving, especially in fertilizers and in the seeding, can be quite high. This, of course, depends also on the strategy of the farmer. If he or she focuses on saving the input or increasing the yields, so this usually doesn't come both at the same time. It's more about selection of what the user would like to do more, but it's possible to achieve 5 to 15% of increase in yields. Those data are based on multiple studies that are done by our customers, but also the customers of our competition that we also like to read. This year, we are also making our own field trials. We don't have the results yet, but we will of course share it in the next year webinar series. So if we look at this variable rate technology adoption, as I said, the things we need is to get a map from some of the sources, put it into the software and send it to the tractor. In this chain, we as a company, we focus only on this satellite part and the space data. And let's look more deeper into what actually are the things that can the satellite do and why the satellite is the best source of data for some of the activities in agriculture. So the right maps for variable rate applications are from satellite due to 3 reasons. The main one is the costs. So it's the cheapest option if you compare the drones or soil sampling and satellites. Definitely with the satellite, you've got the lowest cost because of the price of the data, which is free or very low. The second is it's multi-temporal, which means you get information from multiple years in a standardized quality, which is answering another problem in agriculture, which is the problems of data compatibility and really heterogeneous quality and file formats. So from satellites, you have multiple years with the same quality and the same meaning in the data. And also it's available to combine it. So it provides an input also in the time when there is no field crop already growing. So some technologies are using the cameras that are already on the machinery. So they scan the current state of the crop, and then they, for example, put the right dose of fertilizer. This is very good for some stages of the growth, but for example, for the fertilizing after the season, when you don't have any crop there, again, the satellite data based maps are the best possibility. So what, for example, we as a company do, we provide the maps for the individual applications like fertilizing or seeding or application of growth regulators. We're also helping to optimize the soil sampling, which is one of the key information sources for current smart agriculture. For some of the application on field, you need directly information from the soil samples, but the methodology, how you take the soil samples and how you create the maps based on it differs. Again, we see that for the future, it's not just the map, but it's also about the timing of the application. So with less people available for field scouting and assessing the field phenology in person, the systems that are able to do it automatically will actually help to optimize the timing of the application, and then, of course, their return on investment. And the last thing we see is the combination of different satellite sensors to provide information also in the cloudy weather, because in the spring conditions, especially in Europe, we have multiple days when we have cloudy, we have full cloud cover, which means that no satellite data are available, which means that there's no map to be used, which can cause huge problems and actually slow down the adoption of this kind of services. But with the AI fusion of radar and multispectral data, we are able to solve this problem and provide this map at any kind of weather exactly at the time when it's needed. So this is our approach, how we do it. We provide the API that can be integrated into any kind of system, which means we're looking at these digital platforms that doesn't matter if they're coming from hardware, software, inputs, or any other part of the value chain. And we help them to integrate this part to directly get the benefit into all parts of the value chain as discussed before. So that was the first webinar, the first one, which was more kind of a theoretical and higher level, but we will have 3 more that will be really specific. They're coming in next weeks. Next week we will look at the field crops and soil, and the other week we will look at also the orchards and vineyards. And to give you the idea of how it will look like, so we will, for example, next time we will look directly at some of the applications of variable rate fertilizing, how we approach it, what are the limits of this, and how the farmers are using what's the feedback. So this will be on the next session. I would like to invite you for that. And this is it for today. You can reach us at any time on LinkedIn or directly book a meeting with me to discuss some of the issues in person. I'll be very happy to understand your industry and your point of view. And now we have also time for questions. So I can see that some of you have already asked. So let's look at the questions. What kind of satellite data do you use in your products? Yes, so at the moment the system is based on, of course, on Sentinel satellites from the Copernicus, which we combine with the planet data, as they have the higher revisit and better resolution for some of the use cases, especially at the vineyards and the orchards, as we will be discussing in the next webinars. There is another question. Scouting tool, how does it work? Okay, the satellite data for field scouting are used in a way that you monitor all of the field all the time, and you're looking for the growth anomalies. Once you find a growth anomaly, then usually the agronomist appoint a person who goes to the field and checks what is going on there. At the moment, some of the system can find specific diseases or specific problems, but mostly the systems today are agnostic. So it can point out that there is something weird happening in the field and that somebody should go there. But until now, it's not really able to make it smooth without the person. So it's similar to all the AI discussion that we are having these days. It's not something that will exclude humans from the process, but it will make them work more efficiently and better. So, can you provide primary and secondary nutrients through variable rate applications? Yes, depends on which level. Of course, it's always better to combine the satellite data and the soil sampling for the nutrient levels, and then the variable rate application maps. The nitrogen fertilizing can be based on the satellite data only, but for the other nutrients, it's better to combine the different systems together. What properties do you provide and at what depth? So the satellite monitoring we're using is monitoring only the surface and the crops. So we're not looking at any depth. With our soil moisture monitoring, we're looking at the depth of maximum 7 centimeters. But otherwise, everything is only above ground. So our service is not looking at any depth. What is the validation you do in precision agriculture? So for the validation, it's being done through the field trials. Those are standardized field tests. When you divide the field into different zones that are used for the tests and then for the controls. You do the variable rate applications in different amounts on the different zones. And you put the flat rate on the control zone, and then with the data from the harvesters after the season, you can measure the impacts of the different strategies in one field. So this is how it's being done in standard way. And it looks like there's none other questions. So thank you for your time today, and I'm looking forward to meeting you on the next webinar, which will be about open fields next week. Thank you and bye-bye.